Let's graph the function f of x. Our first step is to find our domain. In order to find the domain, we need to factor both the numerator and the denominator of our function. In the numerator, I am going to GCF the x, so I'm going to have x minus 5. In the denominator, I already have two factors of x minus 1 and x minus 1. For our domain, we look only here in the denominator. We do not want our denominator to equal to 0. So I'm going to let each of those factors and say they're not equal to 0 and solve and find that x cannot equal to 1. So our domain will be from negative infinity to 1, not including the 1, union from 1 to infinity. For step number 2, we need to decide on wholes. In order to decide on wholes, we need to see if the denominator has any factors that cancel out with the numerator. And we can see there are none, so there are no wholes. For step 3, we need to find intercepts. We're going to find both the x-intercept and the y-intercept. To find one of the intercepts, I'm going to let x equal to 0 and then decide what y is. So I'm going to find f of 0. I'm plugging in 0. I get 0 squared minus 5 times 0 over negative 1, because 0 minus 1 is negative 1, and then square it, and I'm going to get 0 over 1, which is equal to 0. So there's one of our intercepts. The other intercept is when we let the y value equal to 0. So let me show you what that looks like. So instead of having f of x, we're going to let that y value f of x equal to 0, and we have x squared minus 5x over x minus 1 squared. Since I have a fraction, I'm going to multiply both sides by this common denominator, which is x minus 1 squared on this side and x minus 1 squared on this side. On this left side, I still get 0, and on the right side, my denominator goes away and I get x squared minus 5x. This is the same thing as just looking at our numerator and setting our numerator equal to 0. So when we're looking for the x-intercept, when we let y equal to 0, it's the same thing as getting our numerator, x squared minus 5x, and setting that equal to 0. I can factor, which would be x minus 5, and then I let each factor equal to 0 and solve for x. So then we solve for x. We have x is equal to 5. So we already have this one where we let x is equal to 0, and then we find the other one must be when x is equal to 5. So those are going to be our intercepts. For step 4, we're going to find our vertical asymptotes. Again, we look in our denominator and we try to find out if it didn't cancel out, then that must be a vertical asymptote. So we're going to find that a vertical asymptote is x is equal to 1. Note that the factor that created this vertical asymptote has an exponent of 2, which is even, so we will see that our graph will go in the same direction on either side of my vertical asymptote, either both to the positive infinity or to negative infinity. To find our horizontal asymptote, we're going to look at exponents. So if we look at f of x, we're going to find that we're going to have x squared minus 5x at the top, and at the bottom when I do FOIL, I'm going to have x squared minus 2x plus 1. And we look at the largest exponents in the numerator and the denominator. In our case, they're equal to each other, so that means the coefficients are going to be my horizontal asymptote. So our horizontal asymptote for this problem will be y is equal to 1. Now we're ready to graph. So let's first highlight all the points that we can graph. We can graph intercepts, that's this one, as well as this one. So let's graph those. I'm going to graph those in blue. So we're going to have 0, 0, and we're going to have 5, 0. We also have asymptotes. We have a vertical asymptote and we have a horizontal asymptote. So I'm going to put those in yellow in terms of highlighted so we can see it. A vertical asymptote at x is equal to 1. So it's right now. What we would normally do if we had a pencil is we would put that to be dashed. But I just wanted you to see that we can also have it highlighted. Our horizontal asymptote is y is equal to 1. And this is going to be a little bit more difficult because it's going to be thicker. But we can see where it's our horizontal asymptote will be here at y is equal to 1. And I did push that one dash because I wanted you to see that we don't want it to be part of our graph. It's just part of our guidelines. So we're ready to graph. If we take a look at our original function over here, we're going to realize that we have something that looks like 1 over x squared. So 1 over x squared is a parent function looks like this. Or, because we didn't do long division, maybe it actually looks like an upside down volcano. Let's see if we can tell from our graph. Well, we can see our axes, so I know this needs to go up towards 1, and it cannot cross my vertical asymptote, so it must be coming down like this. Because of our parent function, we also know that it needs to come down towards this way, and then going towards my horizontal asymptote that way. And now you can compare your graph to that on the graphing calculator.